PV power systems. First of all, we would like to look at some trend analysis about PV power systems. How did PV evolve? And then what are the capacities that we have installed globally in different regions, different places? As far as we know, you will find out that as at 2015, the total installed capacity of PV power plants globally is about 227 gigawatts, and that is as of 2015. You will find out that from 2005 to 2015, that's a span of 10 years, we have the annual additions and then the annual capacity for these 10 years on the screen, as you can see on the screen now. You will notice that this is important for you because you should be able to explain if enough attention has been given to PV installation over the years. You should be able to explain if it is important that PV policies are being instigated, are being brought up by several economic and financial leaders. And how you would know this is that on a yearly basis, you will find out that many more additions are being made annually. So this will tell you that many more people are getting to know about PV on an annual basis in the last 10 years, in the 10 years discussed in this particular teaching, okay? Because if the awareness is not increasing, if the importance of PV power plants or PV systems are not increasing, it simply means that enough attention will not be given to it, okay? It means that it is not solving problems. But because it is solving problems, it is solving energy problems globally, it is getting more or gaining more attention, and then the attention it gains is allowing as many government and organizations, government agencies and organizations and individuals to begin to install more and more and more on a yearly basis. All right, the data we have here is up until 2015. So I'm going to give you an assignment. You have to find out the data for 2016 up until 2019. Data for 2016 up until 2019. That's going to form part of the project and assignment. So please think about it. So in 2005, you will find out that the global installation we have, global capacity is about 5.1, and then addition is just about 1.4 in 2005. In 2006, the addition was just 1.4. So you will find out that in 2007, the addition increased to 2.5, to 6.5 in 2008, and then to 8 in 2009, up until 2015. In 2015 alone, the addition we had was 50 gigawatt in 2015 alone. And that took the total installed capacity to about 227 in 2015. And then total installed capacity started increasing or continued to increase from 5.1 to 6.7 to 9, right up to 16. And it kept going up until 2015 that we have 227. As we speak right now, total installed capacity globally is almost 500. As of 2019, it was about 430 or thereabout. Now, as I speak to you, it's about 500 or even more as I speak to you. So we'll find out, we'll do some research projects and we'll find out the latest update about PV power plants. Okay. Solar PV global capacity by country. Now, we've talked about by installed capacity and annual additions. Now, we want to talk about PV capacity by country, okay? What does this mean? This simply means that which country is installing PV the most, okay? Where do we have the highest installation of PV power plants across the globe? You will find out that we have from 2005 to 2015, you will find out that during this period of time, the countries that are leading in PV installation are Germany, China, Japan, United States, and Italy. Okay, in 2015, you will find out that the country with the highest installation is Germany in 2015, followed by China, right? And then followed by Japan, followed by United States of America, and followed by Italy. Okay, the same trend you will find in 2014. So we can confidently say that in the 10 years that we evaluated, the country that actually has, the highest capacity installed is Germany. If you look at the years from 2005 right up to 2015, in 2015, China had, stepped up their game big time, and they were at par with Germany or even more than Germany in 2015. Okay, so in 2016 to 2019, we have to find out which country is the leader in terms of global installations of PV power plants. Okay, that's going to be part of the project that we are going to work on too. Okay. This particular slide is just talking about the evolution of total installed PV capacity between 2005 and 2015. And it's actually part of the first slide. And then they calculated the percentage of increase, over the years, okay, and in various regions. So let's briefly talk about PV installation and cost across the globe. Solar energy is a sustainable and environmentally friendly alternative for fossil fuels. One of the reasons why we have to pay attention to PV power plants is because solar photovoltaic, when you say PV means photovoltaic, by the way. So when we say solar photovoltaic, and of course we know it is from the sun, all right? So when we say solar PV, we are saying solar photovoltaic. Now, solar photovoltaic is a renewable energy source. It's a renewable energy technology, and then the source is the sun, and then the sun is renewable. The sun is available as often as possible. So that simply means that we would always have access to the sun as long as the earth is in existence. We would always have access to the sun. There will never come a time when we will exhaust the use of the sun. Okay, we can say that during the day, at some point, the sun will not shine. In the night and sometimes in the evening, the sun will not shine. But on a single day, every day, the sun will always shine on a daily basis at a particular period of time, depending on the locations and regions we are in. So this way we can say that we will always have access to the sun. Now, one of the reasons we need solar PV is because there are speculations that fossil fuels are getting exhausted. There are speculations that in the near future, fossil fuels are becoming finite, not available as they used to be to everybody. So if that continues, it means the price of fossil fuel will increase. If that continues, it means that energy generated from fossil fuels, the cost of that energy would also go up. So if the cost keeps going up and then the availability of the fossil fuels becomes questionable, if we don't find sources that will replace fossil fuels, then the entire world would be thrown into a dilemma. The entire world would be in chaos because we may not be able to produce enough energy to meet our needs. So this is one of the reasons we are saying that, look, there has to be alternative sources. There has to be renewable sources that we can easily, assess. One of the other reasons we also focus on, we are focusing, or the world is focusing or tilting towards renewable energy sources now, is also because of the environmental impact of fossil fuels. Fossil fuels have ways of causing issues and problems in the environment. They have the ways of making the environment hazardous. They emit gases into the atmosphere, and these gases could be hazardous to human lives or even other, living organisms in the waters or on the land or in the air. So many reasons why we have to patronize alternative sources and renewable energy sources. And some of the reasons I've explained to you already. So solar energy is a sustainable and environmentally friendly alternative for fossil fuels. This is a very good information for you. Pay attention to it. Now, solar PV and concentrated solar thermal are the two most common and broadly used solar energy systems for generating electrical power. There are many things we use solar energy for. Okay, the energy of the sun can be used to generate, energy, different forms of energy, and so on and so forth. Okay, but when we talk about electrical energy, which is our focus in this course, when we talk about electrical energy or electrical power, there are two types of solar technologies that can be used, solar energy technologies that can be used to generate electrical power. The first one is solar PV, and the second one is the concentrated solar thermal, or CPV. But the most popular ones are the solar PV and then the concentrated solar thermal. All right. In this particular course, we will not cover the CPV, which is concentrated PV. We will not, focus on that in this particular course. But at some point, we will talk about it. Okay. So these two are the most commonly used, popularly used, and then more mature technologies that can be used to generate electrical power from the sun. Solar PV is more fully developed and more economically viable for power. So between these two technologies that are broadly used and common, the most common of them for electrical power is the solar PV. Okay, in recent times, solar PV has been used domestically, it has been used commercially, it has been used on a utility scale to generate electrical power. All right, on a commercial scale and utility scale, and even on a domestic scale to generate electrical power. And we'll be talking about the details of that as we proceed. The global levelized cost of electricity of utility scale solar PV has fallen from 73% since 2010 to 0.1 kilowatt hour for new projects commissioned in 2017. So what does this mean? It simply means that between 2010 and 2017, that's about seven years interval. In those 7 years, the levelized cost of electricity, okay, of large scale or utility scale solar PV has fallen by 73%. So if it fell to 0.1 dollars per kilowatt hour, that's about 10 cents per kilowatt hour. We're talking about US dollars here. So that's 10 cents per kilowatt hour for new projects commissioned in 2017. So if you are very versatile with mathematics, you can calculate backwards and find out what the cost was in 2010 that fell to 0.1. Also, drop in cost of electricity from utility scale solar PV projects has been extraordinary. This is just what we are saying. It's amazing. When it started, it was very expensive. When it started, it was scarce, not readily available. Only few people had access to it. They had not started producing in large quantities. So you will notice that from the graph we looked at, the graph we looked at when we started this teaching, you will notice that as the installation increased, as the installed capacity increased over the years, you will notice that many more people started deploying solar PV. And that would mean that people got more exposed to solar PV, and then people started buying it in large quantities. Installation became, more fluid, and many more people started using it. And the more people, according to economics, if you're familiar with economics, the more people use something, the more it will be produced. And the more you produce something, the less the cost of production. And when the cost of production reduces, it simply means that you can sell at a lower price. The cost of electricity will then become lower if the cost of installation drops due to drop in cost of manufacturing. All right. When you're manufacturing just one or two, the cost is high. But when you're manufacturing in hundreds and thousands and millions, the cost is going to reduce. All right. And that means you can sell cheaper as time rolls by. So that is just the concept behind these. Let's take it a step further. So solar PV O&M. O&M represents operations and maintenance, okay? So solar PV operations and maintenance costs are small compared to their installation cost. Now, this will also depend on the types of solar PV we are talking about. But in any case, whatever the solar PV is, the cost of maintenance is way below the cost of installation. The cost of operation and maintenance is way below the cost of installation. There are different types of PVs. We have fixed PVs. We have single axis tracking PVs. We have dual axis tracking PVs. Okay. So the cost of maintenance, operation and maintenance for fixed PVs will be lower than the cost of maintenance for the single axis tracking or dual axis tracking PVs. When you are tracking the PV, it simply means that there will be some parts of the PV that is moving, and that way the cost of maintenance is going to go up if there are moving parts. But if there are no moving parts, no additional or complex parts added to the system, it's just fixed. The cost of maintenance will probably just be the cost to clean it when it is dusty, and then probably the cost to check it once in a while, periodically, to make sure that everything is functioning the way it's supposed to function. So it requires very low operation and maintenance cost. This is one of the advantages of having solar PV or deploying solar PV globally over the other technologies that we have, the commercial fossil fuel technologies that we have. You will find out that only 1% of system initial cost per year for PV system sized between 10 kilowatt and 10 megawatt is required for the operations and maintenance cost. Okay, only 1% of the installation cost will be needed to maintain the system. So that means if you install the system with $10,000, 1% of $10,000 will just be needed to maintain the system annually. You would also find out that institutions and universities typically have large demand charges, okay, and may be able to reduce these demand charges by installing solar PV. What are we talking about here? Institutions like universities and other research centers and other large organizations, they usually have large demand charges. Why? In the universities, we have dormitories. In the universities, we have offices. Teachers are always in the offices from morning till evening, and then they consume energy, either ACs for cooling, either for cooling or for heating, or for other for computing or technologies, and also in addition to their offices, technology is also being deployed in many classrooms these days, so that consumes a lot of energy too. And in addition to those, when the classes are over in the afternoon, these days classes are not even over in the afternoons. We have classes from morning till afternoons, and then for universities that are large enough to accommodate postgraduate programs, they also have classes in the evenings right into 7 p.m., 8 p.m. in line. Then when that is over, like some other companies, they shut down the company and they all go home, and then there won't be any consumption over the night. In universities and some research institutions, this is not the case. The dormitories begin to consume electricity in the universities, okay? So overnight students are going to be in the dormitory, they're going to be consuming electricity, okay? So you will find out that generally for research, and then for teaching, and then for offices, and then for lighting the environment within the institution, there is usually large demand of energy, all right? And the charges are usually high. So to meet up with this demand, it is more economical to install a solar PV or install large solar PV in universities, in institutions. This will help in cutting, cost, and it will reduce demand from the utility scale of that particular region for that university or for that institution. All right. So this is important for you. Let's take it a step further. So in recent years, universities and large PV plant installers decreased their energy consumption by 8%. This is from a study that I carried out. I did some studies, and I found that in some of the researches that have been done in previous years, and some of the researches that I also carried out, I found out with a couple of other researchers that PV plant installers, the large PV plant installers decreased their energy consumption by 8%. So if you install PV in your institution, your consumption will drop by 8%. They have also reduced their carbon emissions from energy consumption by 14%. So this is making a huge statement about protecting the environment. So if you install PV in your institution, you drop the consumption by 8%, you drop the carbon emission into the atmosphere or other gases into the atmosphere by 14%. The installed cost for commercial solar PV have declined by 59% from 2009 to 2016. So installation cost has dropped by 59%. Okay, so between 2009 and 2016, that's about 7 years. In these 7 years, there's been a huge decline in installation cost. All right, according to NREL, National Renewable Energy Laboratory, in 2016, the benchmark, the installed cost for commercial solar PV at $2.13 per watt, all right? So for every watt that you install, as of 2016, it's about $2. Now the cost has dropped to as low as $1, all right? This is gonna form part of your assignment to a project. You have to find out the current installation cost. Yeah, you have to find out the current installation cost for PV power plants, okay, per watt. I'm going to include this in part of your projects. I will explain to you how you will go about it later. But currently, as I speak to you, in many regions globally, the cost of installing PV is about $1 per watt. In 2016, it was about $2, $2.13. Now it has dropped to about $1 or thereabout per watt. All right. The DC you're looking at there refers to direct current. That would mean before you convert the electricity to AC, before you apply the inverter. So this is just for the installation of the modules. Now the DC part, without considering other components like the inverter in particular. So on this graph, you will find global annual PV module demand and cumulative capacity from 2015. You know, the first graph I showed you was from 2005 to 2015. So from 2015 to 2021, this is exactly what we have. In 2015, 54.7 was added. In 2016, 70.5 was added. In 2017, 70 was added, right up to 2021, where we have a projection of 84.9, 85 is the projection, okay? So what we are saying is that by 2021, we're gonna have a cumulative installation of 670, approximately 670 gigawatt installed globally. Right now, as I'm talking to you in 2020, we have almost, we are getting close to this target, okay? We are getting close to this target already. In 2020, one of the projects you guys are going to work on is to find out, because these are projections, all right? What you can see here for 2020, these are projections. For 2019, you know, we already have, you know, the installed capacity for 2019, which was not up to 507, by the way. But the projections made, whereas at the time we got this information in 2018, this is the projections made that would have been 507 gigawatt in 2019, 584 in 2020 by the end of 2020, and then by the end of 2021, we will have 670 approximately. Okay, this should give you an idea of historical commercial solar PV installed costs. Okay, so you will see from Q4 2009 to Q4 2010 to Q4 2011 to Q4 2012, Q4 2013, Q1 2015, and Q1 2016. Q4 will mean the last 3 months of the year. Q1 will mean the first 3 months of the year. Okay, 1 quarter is equal to 3 months. So Q1 is the first 3 months. Q2 is it's going to be from April to June. Q3 is going to be from July up until September. And then Q4 will be October to December. So Q4 2009 is October to December. And then they compared, you know, the cost of installation of PV per watt, you know, in 2009 and 2010. You can see it was this high sometime in 2009. And by 2010 or thereabout, the cost had dropped to 4.85. In 2011, it had dropped to 3.34. And then 2012 and then 2013, right up to 2016 and above, where it has dropped to $2.13 per watt. Okay, so now we're gonna, this is a trend analysis to give you an idea of what has been happening, okay, over the years. So for 2016 right up to 2019 will be included in our project to find out what is going on in the current dispensation. All right, let's take it a step further. Commercial solar PV system installed cost by system size. So you will find out that as the size increases, the cost of installation drops. This supports what I mentioned earlier when I was trying to tell you that the more production we have, the more installations we have, the lower the cost of installation. So when you are installing 100 kilowatt, you expect the cost of installation, you expect the cost of installation to be higher than when you are installing, let's say 1 megawatt. 1 megawatt is, that's 10 raised to power 6 watts. 1 megawatt is 10 raised to power 6 watts. Okay, so the cost of that is way lower than the cost of installing 100 kilowatt. Okay, so please pay attention, make note of that, pay attention to that. These are the largest PV power plants as at 2017. Okay, so you will find some of them were commissioned in 2015, some were commissioned in 2012, some 2016, some 2014, some 2016. All right, the newest one here is 2017 that we checked, and it was commissioned in India. It is called an ultra mega solar park, and then they use polycrystalline silicon as the type of module for this installation. Okay, I'm going to be explaining what that means later. It's a type of PV technology. All right. So you see that in 2017, we have 900 megawatt, which was the highest then. And then the next is 850 megawatt as of 2017. The second largest was 850 and located in China. And then the third is 648 located in India. And then 579 550 in the United States, different locations in the United States of America, down to 300 megawatt in France. Okay, so you can see it is arranged and sorted in the order of their size or capacity. So the highest being on top and the lowest being at the bottom, 13. So these are the top 13 as of 2017. In your project, you will be asked to list probably the top 10 largest PV power plants installed globally. This is also going to form part of your project too. So please pay attention to that. It's very important. So there are several other projects that you might want to look at here. We have a project here, water canal project, 1 megawatt. The one at Caledonia is about 2 megawatt. The one at the water canal project is about 1 megawatt peak. This is also very important. You might want to pay attention to that. As we continue to discuss, I'm going to tell you the advantages of installing a PV on, having a water canal PV installed. It has a lot of advantages. All right, so we'll check that together. Okay, let's go ahead. We have floating PV power plants. We have one in Japan, one in England. You can see we have 70 megawatts in Japan, 200 kilowatt peak in England. And these PVs are actually installed on the waters, okay, on the bodies of water. All right, this is the end of this lesson. If you enjoyed this video, do not hesitate to give it a thumbs up. Also, let me and others know what you think about this lesson in the comment section. Finally, make sure you subscribe to this channel and click the notification button so you can get notified and updated when new lessons are added. Thank you and see you in the next lesson.